Good afternoon, guys. Hope if you're online, can you just do a thumbs up so I know you're able to hear me? All right, good. Okay, so I'm just going to do a quick roll call, okay? And let's go from there, okay? Okay. Kyra,
Here.
Nisha,
Here.
Alina,
Here.
Vanessa,
Here.
okay. Akshay,
Here.
Tyra,
Here.
Aiden,
Here.
Ben,
Here.
Bailey,
Here.
Eloise, Connor,
Here.
Elaine, Tate, Yaya, Satish, okay. All right, so, I just want to go through a few things with you guys before, last week you guys were not here, everything was online. First thing first, let's start with the homework. No, before that, let's talk about the materials. Is there any student here who does not have the materials right now?
Do I need the purple book for the homework?
Yeah, do you have one?
What's the name of it?
It's called the Kaplan.
No, I don't have it.
Okay. I think we have extra copy. So that's the one. That's the one. You don't have the.
No, I don't have that one.
Okay. Um. But we have an extra copy, so I'll make sure to stay back. Anybody else? Okay. We have done week 1 and week 2 so far. How many of you done all the homework? Okay, 1, 2, 3, 4. Online, 5, 6, 7, 8, 9, 10. Okay, so 11. Okay, all of them online. So you're gonna get caught up.
Yeah,
Okay, take your time. Make sure it's the same order. Okay.
Okay.
Is there anybody who does not have the calculator?
I do not have it on me right now. It's at home.
Okay, we need the calculator. Anybody else? Okay. Last week we did trigonometry pre-calc. We did cover quite a bit of material. The one of the things I'm going to remind you guys again and again and again, especially in mathematics, is what you learn in this classroom for the first time is not the last time you'll have to work on that one. You go home, if you want to watch the video again, if you want to do some extra problems, but that's how you're gonna keep remembering the stuff. If you just think it's one and done, you'll be in for a big surprise. Sounds good? Okay. So we're gonna come back to trig later in the semester, but that's just a major introduction to trigonometric functions, the inverses. There is other things we need to learn, but we'll do that at the appropriate time. Okay. Last week we had Aubrey. What did Aubrey cover for you guys for math? Was it equation of circles and parabolas?
It was like the basics. I think like factoring and like one second. Factoring,
Foil.
marking, and like foil.
Okay, quadratics.
Yeah.
Okay, yeah, that's what I thought. But did she do equation of circle and equation of parabolas? That's the quadratic in the vertex form, the standard form?
Yeah, I think she went over vertex of those.
Okay.
And, I don't know. I think so.
And the quadratic formula?
Yeah.
Okay. Okay. Because that's a heavy loaded topic for you guys, okay? All right, let's shift our gears to circles, okay? I'm gonna continue with that stuff. So trigonometry, we're gonna come back to it, but get your calculators. This is a freshman level geometry, but many people don't know a lot of second semester geometry, so we'll see. Okay, it will be circles. Then I'm gonna pivot to something else later on. Of course, you guys know the area is pi r square, right? The circumference is 2 pi r, diameter is twice the radius, right? You guys know all this small stuff. Now let's get into some real detailed stuff, okay? And I don't want you guys to write anything. Put your pencils down, just listen, okay? Listen. Open page 6 of the math packet if you want to have some reference, page 6. All right? As I said, I want you just listen. You'll have time to write. This is pretty important. All right. So, let's get started here. A circle is 360 degrees. Am I right? If I take two radii, this angle it forms is called a standard angle, or a central angle called theta. Let's call it theta. So that's your central angle. It's made by two radii at the center point. This is called a minor arc. This is called a minor arc. An arc is a part of the circumference, right? It's part of the circumference. A minor arc can be defined in two ways. One is the distance as a part of the circumference, or as an angle as a part of the circumference, because this whole thing is 360 degrees. So what's going to be this angle? Or if it is so many inches of circumference, how many inches is the arc? Okay? If this is minor arc, the remaining would be major arc. So a minor arc plus a major arc is equal to circumference, right? And the circumference can be defined in two ways. One is the distance, one is the angle, 360 degrees, or 2 pi r. So this is, let's say, inches. I'm just going to use that one, and this is in degrees. Make sense? Okay. Next. The space this fills up, like a slice of pizza basically, right? This is called a sector. So sector is a fraction of the area of the entire circle. Sounds good? So you will be asked consistently in ACT on these things: arc distance, arc angles, sector areas. Okay? So let's talk about sector, which is actually very easy. So sector is the fraction of the circle. The area of the circle is pi r square, right? So what's the sector area? So it's a fraction of the circle, and fraction is formed by the central angle. This theta is the angle the sector forms at the center point, and the entire circle is 360 degrees. So this is the fraction that is getting multiplied with the area of the circle to find the sector area. Sounds good? Is that clear? Same with minor arc. If I take the minor arc, which is a fraction of the circumference, so 2 pi r is the circumference, and what's a fraction? Theta divided by 360. That's not going to change. This is not going to change because this fraction stays consistent for the minor arc. Make sense? So what type of problem you'll be given? There will be simple direct problems where they give the central angle, you have to find the sector area. There will be some difficult ones as well, which we'll be doing today. Okay? But the fundamentals do not change, that the fraction can be solved by the central angle. First, go ahead and write this. Does anybody have any questions so far? All right, first problem. Let me explain the question here. The center point O forms a radius at A with 5 inches. The central angle is 24 degrees. Find the arc. This is the arc shape they write. Okay, this is not a straight distance, okay? It's an arc distance. So find AB in inches, arc AB in inches, and sector AOB in inches squared. Go. Let's do the standing instructions again. That if you're done, if you're face to face, just raise your hands and put it down. If you're online, do the thumbs up so that I know how much time you guys are roughly taking. Okay, we have 4 here, 5 online. We have a couple of them. Okay. Again, I want to remind, when I'm doing the problem, I don't want you to be writing things, okay? I want you to be listening and understanding. So let's get started with the arc length. Sometimes you'll get this direct of a problem in ACT where it will be obvious. It's just that you have to know the formula. So to find AB distance, the arc distance, so it's circumference 2 pi r, radius is 5, and the central angle is 24 degrees divided by 360 degrees. It's just straightforward. What I would like you to do is get your calculators, and I'll tell you what I want you to do. Ready? Just follow with me. Do 2 times 5, times 24 divided by 360, hit enter. You get some number, right? What do you guys get?
0.6 repeated.
Something like that, right? Now do math, 1, enter. So repeat, once you get the decimal form, you do math, 1, enter. It converts the decimal into a fraction. Did you guys get it? What do you guys got?
2/3.
So 2/3. See, I didn't touch the pi, right? I'm going to keep the pi as pi. This is how ACT is going to have your answer. 2/3 pi inches. Or if you want to put the 3 pi as 3.14, you sure can do that as well. We get some decimal answer. But ACT prefers having this type of answer, prefers the format. So as soon as you see these type of questions, look at the format of the answers. You guys good? I would like you to raise your hands or do a thumbs up if you're online who got this correct. 1. If you're online, 1, 2, 3. Okay, total 4 of them. Straightforward. Okay. Any questions? Please ask questions. I'm not here to just do a monologue here, okay? I don't want to waste your time or my time. You're here to learn. So don't mind repeating things. Sector area, AOB, sector is pi r squared. R is 5 squared. Theta is 24 degrees divided by 360 degrees. Do the same thing and tell me the fraction form of the answer, keeping the pi as pi. Someone double check that.
Yeah.
Inches squared. Units are important. How many got this one correct? 1, 2, 3, 4, 5, 6. Okay. Good. This will be a direct part. The main problem is people don't know this, the formula. And they may not have heard this. That's where the problem happens. Otherwise, it's pretty straightforward. Any questions? All right. The next question I'm going to give, it was in ACT, a real test, question number 60. Try this one. And what I would like you guys to do is, whenever you're dealing with pi, don't put as 3.14. Those days are gone, okay? Pi is pi, basically. So here you go. This is question number 2. If AB is equal to AC segment line is 5 inches, find the area of the shaded region. This is the shaded region here. Go. You got to think, okay? They're in advanced level. You got to think. You have to understand, strategize, and then start solving the problem. Anyone has any answers? Okay. It's supposed to be a hard question. You're in advanced level. It's going to be hard. Okay, this is just getting started here. First question. Can somebody tell me what is the first thing I need to do? I don't care about the answer. I care about the methodology, the process you're thinking. What's the first thing we need to do?
The area of the circle.
Area of the?
Circle. Like the.
Okay, let's do this. I'll keep you happy, okay? So, let's do the circle, area of the circle, which is pi r squared, so 5 inches, so it'll be 25 pi, okay? Fine? All right, good. Next. Your thinking will tell me how fast you can do this problem. Your first step, your second step, and that's what I'm trying to connect the dots here. These problems are not going to be easy. It's going to be hard. Yeah, what's the next step?
To find the angle of ABC.
Angle of ABC, central angle is required. So this is 5 inches, and AC is also 5 inches. How can I find this?
It's also BC is also 5 inches.
BC is also going to be 5 inches because it's radius.
And 60 degrees.
So it'll be an equilateral triangle. So this will be 60 degrees. Major step. Next. I'm not going to just write the solution. I'm expecting you to share your thoughts. Right, wrong, doesn't matter. We all learn together. What's the next step?
And the sector.
And define the sector. So let me draw the sector so you can see it clearly. So this is the sector. Okay? This is the sector. Am I right? Okay, let's say I did find this area of the sector. Then what? I don't need the sector, I just need this piece. Then what?
Area of the triangle.
Boom. You take this area of the triangle out of it. What's left? This piece. So your first thought process here is, what I would have loved to see in your notes, if you've done it, it'll be amazing. Area of the shaded is equal to area of the sector minus area of the triangle. This is the fundamentals I was looking for. You guys with me? Okay, listen. You can write it down. The rest is easy. This is the basics. So let's start with the triangle. It's an equilateral triangle. So this is 5 inches, 5 inches, and 5 inches. Area of the triangle, well, I'm pretty sure you know the formula, which is area of the triangle is half times base, which is 5 times height. Am I right? So we'll find the height. So this is 60 degrees. So I'm going to take the small triangle here. So I'm talking about this triangle here, okay? So sine 60 degrees is equal to opposite over hypotenuse, which is 5. So multiply 5 both sides. Height is 5 sine 60 degrees. I repeat, you know the equilateral triangle. I need the height to find the area. I'm going to focus on this triangle here. I know this is 60 degrees. Then sine 60 is opposite or hypotenuse. We did this last week. Height is 5 sine 60. Okay? So we got that one. So I'm going to plug it back here. So area of the triangle is equal to half times 5 times 5 sine 60 degrees. So it'll be 25 sine 60 degrees divided by 2. And I can do the math later on, okay? This is the easy part of it. So this is check. Yeah? Making sense so far? Not hard, right, so far? This is the basics. You got this right, the rest becomes easy. Let's go to area of the sector. Pi r squared, which we already find, is 25 pi. That's the area of the circle. Multiply by the fraction, we talked about it, 60 degrees divided by 360 degrees. So this is 1/6, so it'll be 25 pi or 6 inches squared. This will be inches squared. Yes, no? You guys good? I don't want to
I'm
write.
still confused
On which step?
on how 60 is the angle.
Okay, so all 3 sides are equal, right? So that means all angles have to be equal. And an equal,
Oh, okay.
yeah. So an equilateral triangle becomes an equiangular triangle as well. 60 degrees. 180 divided by 3. Right, Alina? I think it's Alina. Yeah.
Yes.
Okay. Yeah, ask questions. It's okay. Ask questions. So we got this. So area of the shaded is equal to area of the sector, 25 pi over 6, minus 25 sine 6 degrees divided by 2. Whatever you guess is in inches squared. Right? Get your calculators, do this, and tell me the answer. Decimal. Put pi as 3.14 here, just to get it done with. Anybody? Is it decimal form have the answer?
2.26.
Someone double check that.
Yeah, 2 punches.
Hold on, don't write this. So, let me start with this one more time. Does anybody have a question on this step? Again, remember, don't fight these things. Embrace this learning process. It's not supposed to be easy. Okay? If it's easy, then anybody can do it, right? You want to put in the effort. You want to make the magical transformation for yourself. So you want to do difficult problems. You want to fail. That's how you learn. Any question on this step? Any question on the triangle part of it?
I have a question.
Yeah.
Can you split the 5 and make it like 2?
Yeah, the only reason we can do the Pythagorean theorem is it's an equilateral triangle. This becomes a perpendicular bisector. This becomes 2.5 and 2.5. Then you can do height squared plus 2.5 squared is equal to 5 squared. You can do Pythagorean theorem that. Can you do it for isosceles triangle? Yeah, you can do that. Not for scalene triangle. But scalene triangle, it's not a perpendicular bisector. Make sense?
Yeah.
So the base has to be the height, the vertical distance has to be a perpendicular bisector to the base. Then only you can do that. I always avoid that because you know trigonometry now. And by the way, there is a shorthand formula for equilateral triangles. Let me tell you this. So, some of our best students we had amazing shortcut knowledge of mathematics. So, for example, area of an equilateral triangle, okay, without doing any of it, can be done using a formula called s squared times square root 3 divided by 4. This is a shortcut formula. S stands for the side value. So s is 25, 5 squared is 25, square root 3 divided by 4. So this entire thing what we have is this. Like this. And I'll tell you how they got this. Sine 60 degrees in trigonometry using radicals comes out to square root 3 divided by 2. Okay? And of course there's another divided by 2 here. So it'll be 25 square root 3 divided by 4, which is exactly matching with this. So, do I expect you to remember this? 50-50. I would love for you to know this. I knew it. But I would love to, you have no choice but you got to know the basics. That's this one. So this works only for equilateral triangles. So there are so many shortcuts. Actually, in a funny one of the ACTs, they actually gave this formula so that you can do it faster. I've seen it twice. Okay, so any questions on the triangles here? Any question on the sector here? Okay. Now you can see some of you have taken our regular classes. Actually, all of you here have taken regular. See the shift in the advanced, right? We focus on 1 or 2 questions and we spend 20 minutes on it. That's difference because you're pivoting towards the most difficult part of ACT and it takes time. This problem in a real ACT test takes 2 minutes. Go ahead, write this up.
I'm plugging 25 pi divided by 6 minus 25 sine of 60 divided by 2, it's giving me like 3 point something.
Okay. Make sure you do this separately. First do this, and then do this, and then do this minus this. Try that and see. And I'll do it in my calculator and see. I'm getting 2.26, Alana.
I'm still not getting that, and I did it separately. I don't know what I'm doing wrong.
I would just do this separately. Okay, I have a question then. Go to the mode and see if your angle is in degrees or radians.
At the top, it
Yeah.
says degree.
Okay, then you should be getting it. Maybe you're plugging some number wrong, or I don't know. Not sure.
Okay, so I'm doing like 25 times 3.4 divided
3.14.
by 6.
3.14.
Yeah, 3.14 divided by 6.
Okay, you get
And then
30.
I do,
You get 13 point
Yeah.
something, right? 13
Yeah.
points. Okay.
and then I do 25 of sine of 60 divided by 2, and I got 10.8.
Yeah. So 13.08 divided by minus 10 point something is 2.26. Again, your steps are correct. Don't worry about the answers. Yeah. So you'll be
I
fine.
got it. Thank you.
And this is one question you should be going home and doing it 3 times so that you can build the quickness. By the way, this is all freshman geometry. Okay. Next. Again, you don't have to write this, listen up. So we just talked about minor arc and major arc, which is formed by the 2 radii at the center point, right? Now, what is this line called in circles? This line.
Chord.
Chord. This line is called a chord. What is this line called? Another chord. All right? So when 2 chords meet at the circumference, they form an angle. Let's call this as theta. And these 2 chords form an arc. This is not the same as 2 radii. This is 2 chords, okay? This arc is called intercepted arc. So let me define this. What's an intercepted arc? It's the arc that is formed by 2 chords meeting at a point of circumference. And the angle, if this angle is theta, the intercepted arc will be double of that, 2 theta. Right on this. So when 2 chords, and I'm gonna label this as well so that you guys can have that. Guys good? Okay. That's next called the intercepted arcs. So we did minor arc, major arc, intercepted arcs. Next. This line is a chord, right? Chord is a line that touches the 2 points on the circumference, and the longest chord is a diameter. You guys know that, right? The longest chord is diameter. If a line is drawn from the center point to chord at 90 degrees, if a line is drawn to the chord at 90 degrees, this line bisects the chord. There is a technical name in geometry for this line now. This is called a perpendicular bisector, because this is actually at 90 degrees and it's bisecting this. Okay? So a line drawn from the center point to a chord at 90 degrees bisects the chord. The reason this is big deal in circles is you actually can find the radius using now simple Pythagorean theorem. I repeat, a line drawn at 90 degrees to the chord bisects the chord, so this becomes perpendicular bisector. Then you can find the radius using a simple Pythagorean or a trigonometry. Make sense? Go to right next. This is again is a chord. Next, again, listen up. If I draw a chord, which is a line segment, it just stays between the two ends of the circumference. But if I extend the line, cutting through the circle, this line is called a secant. So what's a secant? Secant is a line. What's a chord? Line segment, right? You study that in like 5th grade, right? Simple basic geometry. So line extends, line segment has a finite distance. Secant is a line, a part of the secant, which is bound by the 2 points of the circumference, is the chord. Make sense? Go ahead and write this down. Could have drawn the secant a little bit better. Is good? what is this line called? Simple.
Radius.
Radius. What is this line called? Come on. You guys should know this.
A tangent line?
A tangent. This is a tangent. So what's a tangent? Tangent is a line which is always outside the circle and touches the circumference at one point, at the point of tangency. And the radius and the tangent always meets at 90 degrees. You have to know the property of tangents. So repeat, the tangent meets the radius at the point of tangency always at 90 degrees. You guys got it? So when you're, if you have the, people do that, right? They have the keys and you spin it, right? When you stop spinning, the keys fly off. That where it flies off is actually at 90 degrees to the point you've left it. Make sense? So this line is called a tangent. This is your radius. And you have to know this because now I can actually build a right angle triangle. Make sense? So trying to build a right angle triangle has a lot of virtue in geometry. That's what we focus on. Go and write this down. I'm gonna give you guys 2 minutes time to read through this again. Just go through a mental walk down on this one. Again, it's not about just listening to me and be done. You have to go home and reinforce this material. It has to stay with you guys. People don't teach this in high school nowadays, freshman geometry, which is like a big, big deal. They don't get to this material. And the ACT does cover this material. And SAT as well.
Can you go over why the intercept and arc equals the two, what is that called, the circle thing?
This one or this one?
No, the very first one.
This one?
Yeah, is it just the rule?
It's a rule.
Oh, okay.
So if these are the two, if these are the two chords, okay?
Yeah.
So you can see here, as I lower it down, the shrinkage in this arc is significant than this one. So a small impact of this angle has a large impact on the arc distance or the arc angle. So that's why it's double. So you actually can usually simple draw it. No, I don't know if you guys still do it at school. You draw a circle, draw 2 lines, do a protractor, okay? So find the angle, then take a thread and measure this arc, and then convert it to degrees, and it'll be exactly double of this.
Oh, okay.
You see that?
Yeah.
Okay. So you have to take the thread at the time because it's not a linear distance, right? You take the thread and you basically measure the distance, find the length. That length will equal to a certain angle, and that will be double of this angle.
Okay, yeah.
So in our geometry, when we studied this back in India, we actually had to use a thread for all arc distances. So we actually, I specifically remember doing this, where we had to literally measure it. We use the protractor. You can draw any 2 chords and find this, but this is going to be much interesting.
Okay, yeah.
You guys use protractors, right, at school? Yeah, so.
What do you mean by the length equals angle?
So, remember, when you measure this distance, right?
Yeah.
This distance correspond to a certain angle of the circumference. So 2 pi r is 360 degrees, right? You set up a ratio at that time.
Yeah, okay, I see.
Any questions? Okay. Next. What are these two lines called? Radius, radii, right? That's simple. Again, listen up, listen up. This is radii. What is this line called?
Tangent.
Tangent. What is this line called? Tangent. What angle does it form here? Between the radius and the tangent? 90 degrees.
90.
Yep, that's right here, right? And this is also going to be a
90.
90 degrees. And these two lines are equal because they are radii. So there is another rule for tangents. The two tangents, which of course always meet outside the circle, if two tangents meet at a common point outside the circle, both the tangents will be congruent. I repeat, the two tangents, when they meet at a common point outside the circle, formed from the two radii, those two tangents will be congruent. Make sense? Called law of tangents. So now we have 1, 2, 3, 4, right? It's a quadrilateral. These 4 forms a quadrilateral. The question to you guys is, what type of quadrilateral is this?
A rhombus.
What makes a rhombus a rhombus?
All the sides are
All sides are equal. Are they equal? It's a kite. Because in a kite, two adjacent sides and two adjacent sides have to be congruent. This is congruent, this is congruent. You form a kite. So, two radii and two tangents originating at the points of tangency, meeting at the point outside the circle, forms a kite. Then funniest thing is, these kites, we already know these two angles, right? It's already 180 degrees. So if I know this angle, then I can find this angle. Because these are already 90 degrees, right? So if this angle is theta, this arc angle, which is a minor arc, will be theta, right? These two will be same. And this will be 180 minus theta. Because these two have to add up to 180, right? Quadrilaterals, opposite sides have to add up to 180. Go ahead, write those. Ask questions, I don't mind repeating. of these entire what we studied today in ACT may get 3 questions. And all will be the tier 3 questions, the last 20 questions. But if you don't know, right? I've seen this is the most common question I've seen. I've seen questions consistently in sectors and arcs, consistently. Hardly seen this one. Maybe once in 2 years I've seen this. I see this once every 3rd test. This is once in 2 years. So what we covered today, sectors, arcs. On an average ASIC test, I'm looking at between 2 to 4 questions. Make sense? All right, guys, take a 5 minutes break. Rika will be here today, so you'll be starting with ACT English. Okay, 5 minutes break. You guys all stay here, and see you next week. Bye-bye.